Good morning, all of you. In the last class, we have studied about, we have solved the problems based on mole concept, right? Based on molecular mass and how to calculate the number of atoms present in a given weight of substance, right? Today we are going to continue the problems. And take the problem is calculate the volume at NTP. NTP means normal temperature and pressure occupied by one in 14 gram of nitrogen. Second one is 1.5 moles of carbon dioxide. Third one is 10 to the power of 21 molecules of oxygen. That's very important question. Calculate the volume at normal temperature and pressure occupied by 14 gram of nitrogen. These are all the gases: nitrogen, carbon dioxide, and oxygen. Right? We also studied in the last class 1 mole of any gas, 1 mole of nitrogen, 1 mole of carbon dioxide, or 1 mole of oxygen, 1 mole of any gas occupies 22,400 cm cube of space. Right? With the help of that condition, we can easily calculate the volume occupied by 14 gram of nitrogen, 1.5 moles of carbon dioxide, 10 to the power of 21 molecules of oxygen. These three are different. They are given the data in different ways, right? Different forms. Once in the first one, they are given in the gram, in the form of grams, and in the form of moles, and in the form of molecules. The same question and the three different sub questions, right? But finally, you have to calculate the volume occupied by that gas in a given data. Right? The first one, let's start with the first one. The question is very simple: how much of volume is occupied by 14 gram of nitrogen? Right. First one is we know that 1 mole of nitrogen gas occupies 22,400 cm cube, right? 22,400 cm cube of space. And we also know that 1 mole of nitrogen means 1 mole of nitrogen. The mass of 1 mole of nitrogen equals to gram molecular mass. That is 28 grams. Right? Nitrogen molecular mass is 28 grams. Atomic mass of nitrogen is 14. 14 plus 14, 28. 28 gram is the gram molecular mass of nitrogen, right? Here they have given in the grams, 14 grams of nitrogen. So that's why I have convert this mole into gram. 1 mole of nitrogen equals to 28 gram. It weighs. Right? You can easily solve here. 28 gram of nitrogen gas occupies 22,400 cm cube of space. Then the 14 gram of nitrogen gas occupies how much of volume? You have to cross multiply and you will get an answer. That is 14 into 22,400 cm divided by 28 gram. Then after solving this, you will get 11,200 cm cube. You can also express it in liters also, right? That is 11.2 liter or 11.2 dm. That is the answer. 28 gram of nitrogen gas contains 22,400 molecules, then 14 gram of nitrogen contains exactly half of it. Right. Let us come to this one, second one, that is 1.5 moles of carbon dioxide. Well, you can observe here, these two, main question is same, but the sub question is different. The data is in a different form. Here they have given in the 14 gram means weight, but in this case they have given in the form of moles. Then now we have to calculate the same question is volume occupied by the carbon dioxide, which was 1.5 moles. How much of volume occupied by carbon dioxide is 1.5 moles, right? Second one is, we know that 1 mole of, you can easily calculate this one, 1 mole of carbon dioxide, 1 mole of any gas occupies 22.4 liter of space. Then what about 1.5 moles of carbon dioxide? 1.5 moles here is in mole, so that's why I am writing 1.5 moles of carbon dioxide occupies all your space, right? You have to cross multiply 1.5 into 22.4 liters divided by this one, and the answer is 33.6 liters, right? 1.5 moles of carbon dioxide occupies 33.6 liters of space. Let us come to this one. In this question, they have given in the form of molecules the volume at entity, how much of volume occupied by 10 to the power of 21 molecules of oxygen, right? Yes, the third one, we know that answer for third question, that is, we know that we have to write it in molecules, right? They have given in the molecules like 1 mole of oxygen gas occupies 22.4 liter of space, but they are given in molecules, 10 to the power of 21 molecules of oxygen gas occupies how much of space, right? They have given in molecules, so then you have to convert this 1 mole of oxygen into molecules. Very easy. We know that 1 mole of oxygen gas contains how many molecules? Avogadro number of molecules. That means you can write 6.023 into 10 to the power of 23. 1 mole of oxygen gas contains 6.023 into 10 to the power of 23 molecules of oxygen occupies 22.4 liter. Then you can easily get cross multiply. So that is equal to 10 to the power of 21 into 22.4 divided by 6.023 into 10 to the power of 23 molecules. 6.023 into 10 to the power of 23 molecules, and that gives 3.7190 into 10 to the power of minus 2 liters. Very simple. 1 mole of oxygen gas contains Avogadro number of molecules. That Avogadro number of molecules occupies 22.4 liters of space. Then 10 to the power of 21 molecules of oxygen occupies 3.7190 into 10 to the power of minus 2 liters of space. That is the answer. Yes, the next question is calculate the mass of. First one is 1.2. The atomic mass of iodine. 5.2. This is iodine and this is 5.2 gram. Right, this is the question. Calculate the mass of 1.2 gram atomic mass of oxygen, 5.2 gram atomic mass of iodine, 5.6 gram atomic mass of chlorine. And they have given atomic mass of oxygen equals to 16 gram, iodine equals to 127 and chlorine equals to 35.5. So this is the data they have given. So you have to calculate what is the mass of 1.2 gram atomic mass of oxygen. Very simple. We know that first one. We know that 1 gram atomic mass of oxygen atom equals to 1 gram atomic mass of oxygen equals to its gram atomic mass. What is that? 16 gram. I have given right now. 16 gram is nothing but 1 gram atomic mass of oxygen, or we can also call it as mass of 1 mole of oxygen atom. Mass of 1 mole of oxygen atom equals to gram atomic mass. And we can also say that 1 gram atomic mass of oxygen equals to 16 gram. Then you have to calculate what is the mass of 1.2 gram. 1 gram atomic mass of oxygen equals to 16 gram. Then what about 1.2 gram atomic mass of oxygen atom? Right. You can simplify it, cross multiply 1.2 into 16. Right. Divided by 1. So that gives 19.2 gram. 19.2 gram is the mass of 1.2 gram atomic mass of oxygen. So in the same question, that is the second one, what is the mass of 5.2 gram atomic mass of iodine? You know that 1 gram atomic mass of iodine equals to, they have given, that is 127. 127 gram is 1 gram atomic mass of iodine equals to 127 gram. And what about 5.2 gram atomic mass of iodine? Question mark. You have to cross multiply it 5.2 into 127, and finally you will get 660.4 gram. 660.4 gram is the mass of 5.2 gram atomic mass of iodine. Right. The third one, this is also the same question. What is the mass of 5.6 gram atomic mass of chlorine? Right. Yes. The third one, we know that 1 gram atomic mass of chlorine atom, that means they have given 35.5 gram. 1 gram atomic mass of chlorine atom equals to 35.5 gram. And what is the mass of 5.6 gram atomic mass of chlorine equals to 5.6 into 35.5. Then you get 198.8 gram is the total mass of 5.6 gram atomic mass of chlorine. This is all about this question. I hope you understood. Yes. The third one, the next problem is calculate the number of moles and also molecules. Calculate the number of moles and molecules present in 6 gram of glucose. This is the problem. So the molecular formula of glucose is C6H12O6. First you have to calculate the molecular mass of that glucose, right? Molecular mass of glucose C6H12O6. 6 carbons are there, 6 into atomic mass of carbon is 12 plus 12 hydrogens into atomic mass of hydrogen is 1 plus 6 oxygens into atomic mass of oxygen is 16, right? 72 plus 12 plus 96. Finally, 180 gram is the gram molecular mass of oxygen. Molecular mass of glucose is 180 gram. Then you can easily calculate the number of molecules present in 180 gram of glucose and how many moles are present in 180 gram of glucose, right? So let us calculate how many moles present in 180 gram, 6 gram of glucose, right? We know that number of moles to calculate the number of moles we have to follow the relation that is weight divided by molecular mass, right? The weight they ask for how many number of moles present in 6 gram, right? That is weight equals to 6 gram. How many moles present in 6 gram of glucose? 6 divided by molecular mass of glucose is 180 gram, right? That is equals to very simple, 0.033 moles. 0.033 moles present in 6 gram of glucose. Very simple. This is the relation. To calculate the number of moles of any substance, we have to follow the formula weight divided by molecular mass. And we also calculate the number of molecules present in 6 gram of glucose, right? We know that 1 mole of glucose, 1 mole of glucose contains how many glucose molecules? Of course, Avogadro number of molecules. That is equals to 6.023 into 10 to the power of 23 molecules of glucose. Then we have to calculate how many molecules present in 6 gram of glucose. Then 6 gram of glucose contain how many molecules, right? We can calculate in gram, right? So then we have to we can convert this 1 mole of glucose into gram. Then only you can solve it. We know that 1 mole of glucose means the mass of 1 mole of glucose equals to gram molecular mass. 1 mole of glucose is nothing but 180 gram, right? One mass of 1 mole of glucose is 180 gram. 180 gram of glucose contains 6.023 into 10 to the power of 23 molecules. Then 6 gram of glucose contains how many? We can cross multiply. So that is 6 into 6.023 into 10 to the power of 23 divided by this 180. Finally, gives 2.007 into 10 to the power of 22 molecules. 6 gram of glucose contains 2.007 into 10 to the power of 22 molecules, and the same 6 gram of glucose contains 0.033 moles. These are the two answers for this question. That is the number of moles present in 6 gram, that is 0.033 moles, and the number of molecules present in 6 gram of glucose, that is 2.007 into 10 to the power of 22 molecules. Right.